Today's lesson is on differentiating all 6 trig functions. I'm not going to lie to you. You're going to have to work at memorizing them. It's good to know where they come from, especially sine and cosine. There's a quick way to remember it, but you're going to have to see that box, and there are rules, and sometimes you have to memorize the rule. There are times when knowing where the rule comes from makes it more helpful, and there's times you accept the rule and have to know it. And the best way to remember a rule is to practice the rule, not staring at your sheet for 10 minutes and hoping that you'll remember it the next day. Practicing it is the best way. So, the graph of sine x is shown at the right, and it says estimate the slopes. That means slope means what in calculus? The derivative. So, for instance, at 0, what would you think the slope is at 0? Positive or negative? And you would think it's close to positive 1, right? If I go at pi over 2, what do you think the slope is? If I go at pi, I'm just going to go the key points for the slopes. What would you think the slope would be at pi? Negative 1. At 3 pi over 2, 0. And at 2 pi. Can you see how there's a pattern? Over here would be 0, negative 1, 0, positive 1. Now what we're going to do below is we're going to graph it, the slopes. So that means at 0, what did you say the slope was at 0? Positive 1. I'm graphing the derivative. So at 0, the derivative is what? 1. At pi over 2, what's the derivative? 0. At pi, what's the derivative? Negative 1. At 3 pi over 2, what's the derivative? 0. At 2 pi, what's the derivative? Positive 1. Do you see a pattern that's happening? At pi over 2, it's, or negative pi over 2, it's 0. At negative pi, it's negative 1. At negative 3 pi over 2, it's 0. And then at 2 pi, it is 1. I'm looking above at the slopes to give me the y value, right, of the points. So I graph the derivative. I'm going to connect it. Yes, tell me it looks like what? It does, doesn't it? So, guess what the derivative of sine is? Done. What? I know, crazy, crazy. So, the derivative of sine is cosine. Now, they did the rest here for you in a box in terms of the other ones. Tangent, secant, cotangent, cosecant. Do you notice the derivative for cosine is what? It didn't give you an example. Can I just do it quick for you so you can see it? So when I look and I sketch cosine and I look at the derivatives, I'm just going to do this part of it. And I say, okay, what's the derivative here at 0? What's the next derivative? Negative, next one, 0, next one, positive, and then back to 0. When I graph it, at 0, the answer for the slope is 0. At pi over 2, the slope is negative 1. At pi, it's 0. At 3 pi over 2, it's positive 1. And then back to 2 pi, it's 0. When you look at this graph, what did you just graph? That's the derivative. It's sine because it starts in the middle, but what direction does it go? So can you see why it's negative sine for the derivative? I know you're going to make a mistake, and I know it's going to take practice. One's positive cosine, the other is negative sine. Positive cosine, negative sine. Can you see the graph can help you with the signs? That when you graph cosine, can you see it's the slopes are going negative? That's the indicator for negative sine. It will also be challenging when you integrate to make sure you get the signs correctly. You know it's cosine and sine, they're connected, the derivatives are connected, but one is positive and one is negative. So, derivatives. For sine, the derivative is cosine. For cosine, the derivative is negative sine. You kind of saw, right, from the graph to remember it. These, you got to suck it up. So, underneath is if you have a hook, right? The hook is inside the trig function. So if you have a hook, you go times whatever the derivative of the hook is. That's what the u prime is here. For tangent, it's secant squared. For cotangent, it's negative cosecant squared. There is a structure pattern there. But you can see the negative, right? Co is negative. Co is negative. Co is negative. That's something to remember the signs, right? Secant is secant tangent, and cosecant is negative cosecant cotangent. You're going to have to suck it up. You got to know these rules. And how you know it is by practicing. So let's look at number 1. Can you find the derivative of cosine? So what's the derivative of cosine? Negative sine of what? 3x squared times, is there a hook inside the trig function? Done. 2, you're going to have to look inside the box until you know it. But I'm going to tell you, co is negative. So tangent's not negative. So tangent connects to secant, and it's secant. Oh, here, let me write this properly, actually. So I'm going to write this as tangent 5x, and then what's the parentheses so you can see it? Sorry. Do you see how I see that 4 right there? So I wrote it in a way that you don't normally write it with trig, but the reason I stopped putting it in the middle and put it up there is, can you see the power rule for derivatives? So what's actually the first step? What do I do with the 4? Goes in front, right? And then what happens to that? Right? We're not done yet. And then inside is the hook. Well, what's the derivative of tangent? Times secant what? Squared. And of what? And this one actually has another hook, because there's what are those Ukrainian dolls, one inside the other. So the next one, huh? Is that what that is? I'm fascinated by those things. And then the derivative of 5x is 5. So can you see there's a hook within a hook within a hook? Yes, you could go 4 times 5 and put a 20 in front and make it look prettier. But can you see that exponent 4 meant that there's a couple hooks inside it? All right, number 3. Can you take the derivative of that? Cosecant. Co means it's going to be negative. And you repeat cosecant of whatever's inside, which is t over 2. And then what goes with cosecant is cotangent, also of t over 2 times. So the first part is just following the rule, right? The end part is there a hook inside it? What's the derivative of t over 2? That's it.
So will we do the product rule on the left hand?
Let's look. Number 4. Do you see e to the negative 2x times cotangent? That's definitely a product rule. You're multiplying 2 variables together, right? The same variable, but you're multiplying them together. What is the product rule? What's the first? E to the negative 2x times what? The derivative, right? Co means it's going to be negative. You can look in the box. What's the rule? Is there any hook here for cotangent x? No. Okay, so that's the first times the derivative of the second plus the second times the, what's the derivative of e to anything? Is there a hook involved? Is there here in the exponent? Done. Turn the page. Okay, A. Without a calculator, find the slope. And when I say slope, they really mean what? Find the derivative when x equals that value. Step 1 is I have to take the derivative. So what's the derivative of y? Start with 3. The derivative of cosine is negative sine. So it will end up being negative 3 sine negative x. But the fun part is, what's the hook for negative x? So really a negative times a negative really is positive 3 sine negative x. Do you see how I did that? Next, you plug in pi over 2 and then simplify it. So when you put in pi over 2, it really ends up being negative pi over 2. And then could you tell me the exact value of that at pi over 2? So negative pi over 2 is where in my unit circle? At the bottom, right? And what's the y value at the bottom? So 3 times negative 1, the answer is, got it. B uses the same one, but this time we're finding the slope at negative pi over 3. So now I'm going to plug in negative pi over 3 into the derivative. Notice in this case, the negative and the negative angle will make it positive. What is the y coordinate at pi over 3 on the unit circle? Pi over 3. What's the reference angle? What's the y coordinate up there? You can do it. Nice. So if you put that together, that's 3 root 3 over 2. You have to know your unit circle. All right, number 6. I was going to go to 7. 6. What does it say? The limit as x approaches 1. A limit question is what type of problem? That's it, right? Plug and chug, right? Done. So when you plug in 1, what value do you get? 1 take away 1 is, and the value of tangent at 0 is 0. And then in the denominator, plug in 0. Ln 0, the value is 0, right? That's one of those properties. So it is 0 over 0. So we can use L'Hopital's rule. Make sure when you apply L'Hopital's rule that you keep the limit notation. What's the derivative of tangent? You can sneak back. Minus 1, and the hook is just 1, right? What's the derivative of ln x? Now what are you going to do? Plug in 1. This time you can actually answer it. So, don't assume that answer is 0. So, secant squared 1 minus 1. Now 1 minus 1 is 0. But what it's really saying is this. What is the value of secant at 0? Go back to your unit circle. At 0 degrees, the point is 1 and 0. Secant's the reciprocal of cosine, right? The x-coordinate. So what's the x-coordinate there? 1. What's the reciprocal of 1? 1. So this is really 1 squared over 1, which just equals 1. I know it's easy to assume that answer is 0 on top, but you have to know your unit circle. All right, last one for the lesson, and then you get to practice. Find the x values of the relative extrema. Do you notice now we're going from like unit 2 now all the way to unit 9 using everything we need to do? Oh, you should say thank you, right? Not shake the head, right? It's awesome. Thank you. There you go. How do you find, and relative extrema means either the local max or the local minimum. How do I find that? The derivative. And I find the critical numbers. What's the derivative of sine x? And what's the derivative of negative? Or what's the derivative of cosine? Negative sine x. So when I simplify it, it's cosine x plus sine x, and I'm going to make it equal to 0. The other would be, is there anywhere that makes it undefined? The answer is no, because they're both continuous. There's nothing that would make it undefined for any value of x. So now how would I solve that between 0 and 2 pi? So one way to think through this is to make them equal to each other. So I'm going to subtract sine x. Is there an angle where they would have the same value, but one's positive and one's negative? So think of the unit circle where the x and y coordinate are the same number, but one's positive and one's negative. So I want you to think of a 45-degree reference angle, right? Root 2 over 2 and negative root 2 over 2, right? So there are two places where that's true. So at pi over 4, they're the same, positive, positive. But in quadrant 2, 3 pi over 4, one's positive and one is negative, and it satisfies the equation. At 5 pi over 4, the same sign. Doesn't help. Keep going to quadrant 4, 7 pi over 4. So those are the two places that solve that equation. We're now going to draw a number line, a first derivative number line. Hooray. Yay. And we're actually going from 0, and it's included, to 2 pi. So it doesn't go forever in both directions. It goes 0 to 2 pi. When I test a number between 0 and 3 pi over 4, what am I doing? I'm seeing if it's increasing or decreasing. And I test in the derivative right here, right? Cosine x plus sine x. What's a nice angle I could test to see if it works between 0 and 3 pi over 2? Pi over 2, right? I like that one, right? Because it's an axis angle. So if I plug in pi over 2, cosine is 0, sine is positive 1, add them together, and the answer is positive. What's a nice angle between 3 pi over 4 and 7 pi over 4? Pi, right? An axis angle, pi. So the value of cosine pi is negative 1. That's 0, so together that's negative. And then what's a nice one between 7 pi over 4 and 2 pi? It won't be an axis angle. So you could do like 11 pi over 6. Positive is bigger than the negative. So 11 pi over 6. Cosine is root 3 over 2. Sine is negative a half. Root 3 over 2 is bigger. So it's going to be positive. What did I find? Where is the x values for the extrema? So there's a local what at 3 pi over 4? Right? And there's a local min when? When x equals, notice it doesn't ask for the points. So there's a local max at 3 pi over 4 and a local minimum at 7 pi over 4. All right?